Welcome back to Stewart Science. Today we're talking about calculating kinetic energy. So this video is going to be kind of similar to my last video where we talked about how to calculate gravitational potential energy. And we talked about where that equation came from and some examples of how to use it. But today we're talking about how to calculate your kinetic energy. So first of all, just to recap in case you missed the first video, we talked about how energy comes in a bunch of different categories. Energy is defined as the ability to cause change. And so there's two big broad categories: kinetic, which means doing something, and potential, which means stored. And so we talked about how potential energy can be stored in a lot of different ways: elastic, chemicals, gravitational, and mass. And we talked about how kinetic energy also can be broken up into several different categories: rotational from spinning, sound, thermal energy from heat. So lots of other different categories for kinetic energy. But so when I say kinetic energy, what I mean is translational kinetic energy. Energy from going one place to the other. And so there's an equation for that, but let's think about it first. If we have these two individuals here, this guy and this guy, those are obviously very different sizes. And so if they were running at the same speed, this guy would cause a lot more change to the runner than this guy. If they hit each other at the same speed, this poor dude here is probably toast. Because the bigger guy has the ability to carry more energy. So just like with gravitational potential energy, mass plays a role in how much energy something has. The other thing that affects this would be speed, because a boulder that's going slow, like this one right here, is going to cause less change than a boulder that really gets moving, like this one too. So velocity is another factor that contributes to how much change can happen or how much kinetic energy an object has. And so the equation that scientists came up with is K equals 1/2 m times velocity squared. And what this means is that the velocity is about twice as important, maybe not about, is twice as important when calculating the kinetic energy as the mass is. But those two items, m for mass and v for velocity, those are the contributing factors to how much kinetic energy something has. And in case you missed the last video too, energy is measured in joules, Joules. This is a guy's last name, the scientist who did a lot of work with energy, not like jewels in your crown. So we're going to use this information to find how much energy something has. If you know how fast something is moving, you can also find how much energy it has if you know its mass. So if you know those two pieces of information, let's say I give you 11 meters per second and 65 kilograms, 11 meters per second, that's about as fast as a person can run. And 65 kilograms is about the weight of a small person. So you put this in for the M, you put this in for the V, and then you just use your calculator to run the numbers from there. So this goes here, this goes here, and so what you're going to end up getting is K equals 1/2 times 65 times 11 squared. And so all you have to do from this point is type it into your calculator. And if you want to get really detailed, you can kind of break it down into multiple steps. So you maybe want to start with 11 squared, which is 121, and then take 0.5 or 1/2 times 65, so we're resolving some terms. We get 32.5. So if we do 32.5 times 121, we get K equals 3932.5. And the last thing we need is a unit. The unit is joules. So here's our answer, 3,932.5 joules. And again, we got that just by putting the information that we know that we're given into the equation where it goes and then just typing it into our calculator. It's that simple. We're going to start with another example involving velocity and mass. So this 9 goes in for velocity because it's meters per second. This 92 goes in for mass because it's kilograms. And so we just plug this back into our equation. K equals 1/2 times 92 times 9 meters per second. So this is a slower person, but having 50% more mass. So we went from 11 to 9 meters per second, but we went from 65 to 92 kilograms. And we'll see what that squared in the velocity does to our final number. So we just go to our calculator and start typing it in. Oh, this is 9 squared, by the way. Don't make that mistake. If you make up a mistake in this problem, it will be because you forgot that squared on the velocity. So 9 squared is 81, and then 1/2 times 92 is 46. So 46 times 91, 81, equals K. And that equals 3,726. Just need a unit, joules. Now let's look at one that involves algebra. Now I give you different information. I give you your energy, because that's in joules, and your velocity. So then, again, you just go plug these up where they belong. This goes in for the V, this goes in for the K. And so the thing that we're looking for is this M. Mass is our missing information. So we just need to use a little bit of algebra after we set it up to find that missing information. So here's the setup. 3, 2, 0, 0, that's our energy, equals 1/2 times M times 9 squared. Now, different people like to do different things, but we have to remember our order of operations. So to solve this using algebra, we need to take care of that first. So 9 squared is 81. We need to solve that first. Exponents come before multiplying and dividing. So then we have 3,200 equals 1/2 times M times 81. Now, different people do different things here. Some people like to move the 81 over first and then move the 1/2. Or you can combine like terms and then move it all in once. That's what I'm going to do. I think that's the better option. So I'm going to combine 81 and 1/2 because they are like terms. So 81 times 1/2 is 40.5 M. And so to get M by itself, I just divide both sides by 40.5. When I go to my calculator now, I do 3,200 divided by 40.5, and I get 79.01, if we're going to be technical, kilograms equals my mass. So 79.01 kilograms. Now, there's one more thing I can do to trip you up here, and that is ask you to solve for velocity. And what makes this harder isn't the math or isn't the science, it's the math. What makes this harder is the math, not the science. Science is the same. All you're doing is looking at your information here and plugging it where it goes. So put the 75 in for mass and put the 3,300 in for joules. But the issue is now our variable, which is velocity, is squared. So our final step is going to have to be to undo that square. And we'll get to that in a second. So set it up the exact same way. Let's say I have 3,300 equals 1/2 times 75 times V squared. So all I did was replace the variables with numbers that we know. Now I need to combine these like terms right here. Combine those terms. So 1/2 times 75 is 37.5, I think, but I'll double check. Yep, 37.5 times squared equals 3,300. Now I need to get this off, so I divide both sides by 37.5. We get 88 equals, but we're not done yet, v squared. Now, what makes this a little bit more challenging is because some of you don't know what to do when you get here. But in algebra, we're trying to undo what's being done to the variable. So if it's being multiplied, we want to divide. Or if it's adding, we want to subtract. And so since this one's being squared, we want to take the square root, which means we would do this little doohickey. So we take the square root of 88, and we get 9.38 equals V. The last thing we need is a unit, and our unit is meters per second. So there's how to calculate kinetic energy. There's how to use the equation. What makes this difficult for this equation isn't the science, it's just the math. It's just the algebra of getting our variable by itself. It's a pretty simple equation. All we have to do is put our information where it goes in the equation and then find the missing piece using algebra. As always, this is Mr. Stewart. Keep learning no matter what.